children. In today's class, we are going to learn about mathematical logic. The most interesting and easiest section in our book. We are learning statements. It's somewhat like an English class. Actually, statements are the building blocks for mathematical logic. But we have many types of statements. All such will not come under logic. What are the types of statements that we already know? Declarative. So declarative, when I say declarative statements can have a true value or a false value. But we cannot say both for them. Either true or false. So that is declarative. Second idea, imperative. Suppose I tell you, go bring a book or get me a cup of coffee. So these are commands. Can you please excuse me? So these are some excuses that we give. So these are some commands for which I cannot say true or false. It's just a command. But exclamatory statements, emotions, feelings, how do you express how beautiful you are? This again I cannot say whether it is true or false. So how beautiful Taj Mahal is just an expression. So no way of telling true or false. The next one is, are you listening to me? Is that book available in that shop? So these are questions. So interrogative statements are there. We are not going to deal about these statements. We are going to deal about statements that has a value true or false. There are some open type. I can say, he is a very good man. But that is my idea. It need not be true for everyone. Another person may say he is bad. So, good or bad, we say, depends from person to person. Such type we say open type, where opinion varies. So, we are going to deal about statements for which I can say truth value is truth value. Doesn't mean it is only true. It can be either true or false. When it is true, we denote capital T. When it is false, we denote capital F. Associating T and F is the main section we are going to deal with. When it is T and F or when it is T or F, the word and are are not. These three we say logic gates. So we have and, are and not. And, or, not. What are the symbols for them? We say conjunction, disjunction, negation. Conjunction. The word conjunction we say and. Disjunction are. Negation not. Let us see the symbols. And you have N. It looks like this symbol, upward arrow mark, like our meat symbol. R goes like this. This symbol will come, V symbol, or I will say our join symbol. And not, you just put a line like this. Now what we understand? Given two statements, say P and Q. P I can say T, T, F, F. What is this T, F? T tells the statement is true. F tells the statement is false. Both we call truth table. So a table showing T and F, the values we call truth table. For a particular statement, the idea may be either true or false. That value we call truth value. And the table showing the truth values we say truth table. Now, P and Q, what does it tell? Both are T alone, it is T. Even if one F is coming, my answer is false. So, and symbol tells me both are true, my answer is true. In all other cases, it is F. R symbol, what does this say? One true comes also, my answer is true. So, true, 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 and the last one alone false. When both are false, my answer is false. This symbol tells me both are true alone, it is true. Whereas this symbol tells me both are false alone, it is false. All other cases, it is true. And what does not tell me? Not if P is T, T, F, F. Negation tells me change and say. If I say T, negation P will be false. T tells me false, false tells me true. So what do we do? Just change it. Just reverse it. T becomes F, F becomes T in negation. Having learnt what is and, are and negation, we can easily do the exercise problems. How many statements are given? 2. P, Q. 2 statements are given. Remember to assume the table in this way. Double T, double F. Single T, single F. Double T, double F. Single T, single F. Now the question is, if there are 3 statements, how will you assume that? When there are 3 statements, consider P as 4T, 4F. Just for remembering, we give the technique of learning. 4T, 4F. For Q, assume double T, double F. Again, double T, double F. For R, you can take single T, single F, single T, single F and continue. So now you can check. T, T, T will not come anywhere else. The 3 combination should not repeat. So we have framed in such a way that no combination repeats. There are 8 rows. How do you get how many rows? When there are 2 statements, 2 power 2 rows will come. That is 4 rows. When there are 3 statements, 2 power 3, that is 8 rows will come. This also important for our objective type questions. So how many statements are there? 3 statements. How many combinations will come? 2 power 3. Why always I say 2 power? True, false. There are only 2 options. So 2 options, power. How many statements are there? So 2 statements P and Q. My rows will be 4. 3 statements, the rows will be 8. How to remember the rows? For P, 4T, 4F. For Q, double T, double F, double T, double F. And for R, TF, 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 TF. And you can check no row is repeated. No combination is repeated. Conditional statements. Conditional statement says, condition on one thing. If P, then Q. So what does the conditional statement mean? If P, then Q. We write P to Q. The symbol like this way. How to fill up the table? For remembering this table, let me give you an idea. Tough. Remember this code word. For P to Q, remember the code word tough. So that tells me TF alone gives me F. Whenever you get TF, my answer is F. All other cases, it is true only. So to remember P to Q, if P, then Q. That is the question. How do I remember? This is tough, let me say. Tough, T-U-F-F, ignore T-U. T-F comes, my answer is F. T-F comes, my answer is F. The remaining options T will come. By conditional statement, if P, then Q. If Q, then P. Both ways it is true. So what do I understand? Both must be same. If P is true, Q also should be true. If P is false, Q also should be false. So whenever they are same, my answer is true. If this is T and that is F, or this is F and that is T, it is false. So biconditional tells me both must be same to get true. both must be true or both must be false to get my answer as T. The remaining cases, if they alternate, my answer is immediately F. Exercise 12.2, question number 6. Negation P and negation Q. Negation P and negation Q. How many statements are there? P, Q. And a combination of some operations. So PQ is my question. Consider P as double T double F, Q as TF. So we have got the 4 combinations. 2 statements P and Q. So number of rows will be 2 power 2, that is 4 rows. Now to proceed with the problem, one by one we shall do. First I am doing negation P. What do you mean by this word not P? Change. This is P. Here T, I will write F. T becomes F. F becomes T. Negation Q. Same idea. T becomes F. F becomes T. T becomes F. F becomes T. The next one, I want negation P and negation Q. What does this word and mean? Both are true. It is true. Both are true. It is true. All the remaining will become false. So, first question, negation P and negation Q we have completed. Second part of the question, I want to find out negation P and negation Q. So, not Q already we have completed. P and not Q we shall do. This is P and this is not Q. What does this word and tell me? Both are true. My answer is true. So, TF, it is F. TT, it is T. FF, it is F. FT, it is F. So, which column I want? Place your finger, find out. Both are true, it is true. Otherwise, it is false. Now, I want not of this answer. Not tells me just change. F becomes T, T becomes F. FF becomes TT, and this is the answer for second subsection. You may be given any combination of not and are in the exam. Not necessarily as in the exercise. Any combination you must be able to attempt yourself. Third subsection, we need to find PRQ. What does this word PRQ tell me? One true comes also, my answer is true. So both are false, my answer is false. All other cases, minimum one true comes, my answer is true. Both are false, my answer is false. Now I want negation Q. Not Q tells me change and write. TF will become FT. TF will become FT. Now we want R. P or Q or not Q. So combine these two. Again R symbol. R symbol tells me both are false. My answer is false. But here TF, it is T. TT, T. TF, T. FT, this is also T. Now all the elements, that is all the final column entries are T only. Fourth subsection, we need to find negation P implies R and P double implication Q. How to find it? When you have the third letter P, Q, R, 3 statements are there. How many rows will I create? 2 power 3, 8 rows I must create. How to create the 8 rows? The first statement P, put 4 T's, 4 F's. The second statement Q, put double T, double F, double T, double F. And the third statement R, Let us put alternatively T and F. Now, I need to find out not P. What is the formula for not P? Wherever T comes, put F. So, 4F will come and 4T will come. We have just put T as F, F as T. Do not use any stylish way of writing T and F. They must look T as T and F as F. Let us not write T like F and F like T. So no confusion. It must be having clarity. The next I want not P to R. Not P to R. What word we have to remember? Tough. For this symbol, I told you, remember tough. So, TF comes, my answer is F. How must I see? Not P to R. So, see in this way. TF, check where TF is coming from here. T is not at all here. Here I have. So, TT, no. TF, F will come. TF, F will come. In all other cases, it is true. Remember, this symbol tells me TF becomes F. So, first this letter, then this letter. So, reverse and read. TF becomes F, TF becomes F. The remaining options will be true. And so, we have completed first part of the question. Now, I want P double implies Q. Biconditional statement, how to do it. For biconditional, what did we remember? Both are same, my answer is true. P, Q. So here we are. Both are true, it is true. Both are true, it is true. Changing, it is F. If it is changing, F. Both are changing, F, changing, F. That is, both should be true or both should be false. One true, one false and all, my answer is F. Here, both are F. So, T will come. Both are F, T will come. Biconditional says, P implies Q, Q implies P. Therefore, both must be same to give me true value. Both are F also, it is true only. Now, I need to find out negation P to R and P biconditional Q. Here the symbol is AND. So these two column I must see. AND tells me both are true, it is true. All other cases it is false. So as we check here again, both are true, it is true. Other cases it is false. So filling three statements P, Q, R. Let us remember 4 T's 4F, 2 T's 2F, single T, single F. Not tells me T will become F, F will become T. Implies, this symbol tells me TF comes, my answer is F. The remaining cases it is true. Biconditional tells me both are same, my answer is true. Other cases it is false. And both are true alone, it is true. Other cases it is false. So these are special questions where we are using all types of operations. So be familiar with such problems.